it's been a while. Today we are learning one of the fundamental techniques in generative graphics, feedback. This artwork will serve as an example, and at the end of the tutorial we'll make it audio-reactive. A little warning here, the following instructions in the tutorial will be voiced by AI. I hope it will make it more understandable, especially for those who is not used to Slavic accent. Anyway, let me know what you think. Maybe I'll stick with it, maybe not, we'll see. Thank you for subscribing and leaving comments, and let's go. First of all, we'll need some pixels, sort of a generator. Let it be a circle top. We need to set the resolution in the Command tab, but since I'll use the resolution more than once in this project, it would be more convenient to store the resolution values in a constant chop. Add one more channel, rename the channels, set resolution values, and let's rename this chop to resolution. Reference the values in the circle top. Then, bring up the feedback top. The feedback top is a really simple operator. It can work in two modes, which you can switch between in the reset parameter. When reset is on, the feedback just passes the input image. When reset is off, it passes the target top. But in this example, there's not actual feedback effect. The feedback occurs if I put some operators downstream the network and refer to one of them. Let's add a transform top and a null top. Rename the null into feedback target and make it an actual target for feedback. Now, in transform top, I'll slightly decrease the scale. What's happened here? First, we updated the feedback by pressing pulse button. It means that for one frame, its input was circle. The feedback top saved it because the target top parameter was empty. When we attached the target, it started to receive the feedback target top as an input. We could represent it like this. In fact, such representation would be even more correct. Until there are no changes within the chain, the image remains still. But when we reduce the scale, the feedback top receives the smaller circle in the next frame. And in the other next frame, it gets even smaller. The cycle repeats infinitely. Let's go back to our setup. To reset the feedback more conveniently, let's bring up the keyboard in chop and connect it to the pulse button of feedback. Now, every time I press 1, it resets and the animation repeats. Before we go next, let's create a render window. Add a null top to the end of the chain, enable display, then divide the screen into two sections, select top viewer on the right, and on the left, right-click, disable backdrop tops. Add an RGB key top to fill the background. Okay, there are two downsides of the current network. First, it requires the before-mentioned manual reset, and second, it's predictable. We can solve both issues with just a few additional operators. Add a noise top and a display stop. The display stop will take the image from the first input. Let's put our feedback here, based on the pixel values of the image from the second, in our case, noise. The default values of the displays are usually too high, so let's decrease them. And in the noise top, I'll change the type to Perlin 3D. Not necessary, but I just slightly prefer this one. Turn off monochrome since we need RGB values for the displays, and in the Command tab, I'll refer to our resolution. To animate the noise, I'll go to the Transform tab and write a Python script that will continuously translate the noise along Z-axis. It moves too fast, so I'll multiply it by 0.1. Let's delete the transform top. The movement caused by the displace operator will be enough for us today. Connect the displace top to a feedback target and press 1 to reset. And now we have a fluid shape that moves completely without our intervention. However, its fate is also unpredictable. It can cover the screen with white color or wash away completely. To avoid this and to make the fluid look more interesting, I'll add an edge top, which recolors each pixel based on its neighbors. Tweak the parameters a little. It's already a nice texture, but I want something to constrain it, some shape that creates boundaries. Let's duplicate our circle. Add a multiply top and connect it like this. We've just created a mask. To make an outline, I'll duplicate the circle again and change its parameters to leave only border. Then, combine it with the main layer using the Add Top. What's interesting about feedback is that its speed is highly affected by the FPS. Of course, you can change the noise or other parameters, but it will also affect the look. So if you need to leave everything as it is and just slow down, reduce the FPS to a compromised value. To create a background, I'm gonna use the layers that we already have, but process it with another feedback chain. Add a multiply top, connect the edge and circle's outline to it, then add another feedback top. Let's also reference our button here. And then add a transform top. I'm gonna do the same thing we did in the beginning of the tutorial. Let's increase the scale. We don't see anything in the preview yet, because the feedback's target top is empty. However, if I reference the transform top, I'll be infinitely increasing the scale. So we need some visible pixels to be present on screen all the time. Let's combine the input of the feedback with the transform using the overtop. And reference it in the feedback top. Now we've got something. Let's merge it with the main layer. I think Add Top will work fine here. Now I want to reduce the brightness of the background a bit. I'll use the level top for that. Let's make the circle softer here. Next, I want to add more movement, so let's rotate the circle. Add a transform top and an LFO chop. The LFO is generating a continuous wave. That's exactly what we need for rotation. Connect it like this. We just need to change the waveform to ramp and set its amplitude to 360, a full circle cycle. The frequency will affect the speed. So we're almost there. As usual, I'm adding some gentle post-processing, which probably doesn't require extra comments, so I'll just show my workflow. I think post-processing is something that's driven mostly by the artist's taste and not external rules. Some like it bold and heavy, I prefer barely visible. It's totally up to you. Now let's add some audio-reactivity. Since the focus of this tutorial was on feedback, I'll keep the audio-reactive part simple. Let me know if you want more in-depth audio-reactive visuals guide. Before we add the audio file, let's simulate the kick with the L4 chop. Otherwise, we can get tired of hearing the same sample over and over again. Bring up the null and let's name it pulse. Now, I just think of parameters I want to animate with sound. Let's start with the circle scale, which can be changed in the transform top. Add a timer chop. Make sure the pulse goes into its second input. Decrease the length to 1 or a smaller value. And in the Outputs tab, turn off everything except timer fraction. We don't need the rest. I want the circle become bigger when the kick drops in and then gradually decrease. So I'll just use a constant chop and a math chop to subtract the receiving value from 1. We'll use this math chop as a base for other animations. But now let's add a null chop and name it scale. Reference it in the transform top. I don't need such a dramatic animation, so I remap the values with another math chop until I like the result. Another thing I'd like to move with sound is the background speed. As you might remember from the beginning of the tutorial, the scale in the transform top within the feedback chain is responsible for that. Let's duplicate the second math chop and remap it with the values needed to change the speed. And don't forget to add the null. I'll name mine speed. Repeat the same process for the display stop. You can choose almost any parameter you want. Here I also decided to make the outline of a circle brighter. Now, a slightly more advanced part. I want to make the seed of the noise change with the sound, but each bar would be too frequent. I want it to change every fourth bar. It means that I need to count the kicks and pass one only each fourth time. Add a count chop. Go to the Count tab and choose Limit from minimum to maximum. The minimum value remains 0 and in the maximum type 3. When we count from 0 to 3, we get 4 counts. Then the cycle repeats. Next, add a logic chop and set its first parameter to on when equal to 0. Now it passes 1 only on the first kick out of 3. So how can we randomize the noise seed with that? Here comes the almost hidden feature of the pattern chop. Set its type to random non-repeating integers, length to 1, since we need only one value, and increase the range to, let's say, 999. Now you can randomize the values within the set range with the trigger button. Connect the logic top to it. Add a null and connect it to the seed parameter in the noise top. Okay, the last parameter before we add the music. Now let's add the track. Drag and drop it to the network. To play and hear it, bring up an audio file out chop and connect your audio file to it. Then go to the palette and under the Tools tab choose an audio analysis component. Bring it to the network. Connect your audio file to it. It analyzes the full spectrum of your track, but we need only kick. Let's add a select chop and under the channel names choose kick. Rename to Chan 1. Connect it instead of the LFO to pulse. By changing the length in the timer chop, you can make the animations more fast and pronounced or slow and smooth. And that's it. Thank you for watching this video. I hope it was clear and you've learned something new. See you in the next tutorial.